Fruity Fizz soft drinks bottles its products in 500 milliliter containers. So the table shows the frequency distribution for a sample of 200 bottles. So this is example number 2. So here's the table down below. Part A, calculate the relative frequency in the table below. So relative frequency is just taking each frequency value and dividing it by the total frequency. So if you added up all these values, you'd find that the total number of tallies, you could say, is 200. So you have 200 tallies here. So the relative frequency, okay, and we know this is correct because we have a sample of 200 bottles in the question. So the relative frequency is just going to be the frequency value divided by 200. Okay. And the reason why we calculate relative frequency is because it's like probability. It's just a way for us to determine our probability density function. So it's going to be like probability, but it's just specifically for a sample of 200. So relative frequency values. So for 0 frequency, we have a relative frequency of 0, 0 over here as well. 2 divided by 200 is 0.01. Here we have 0.055. 43 divided by 200 is 0.215. And filling out the rest of the values here, I have 0.405, 0.240, 0.070, and 0.005, and then 0 at the very end. Okay. Part B, use the table to determine the probability that a bottle will contain less than 500 milliliters of soda. So for 500 milliliters of soda, what interval are we looking at here? Well, we're looking at the interval between 490 and 500. Okay. So what I'm going to do is add up these relative frequency values, and I use these as the probability values. So here we're going to add the relative frequencies from 490 to 500 milliliters. And if I add those values together, well, we have a 0 plus a 0 plus a 0.01 plus a 0.055 and plus 0.215. Altogether, their sum equals 0.280. So the probability that the bottle in that 200 bottle sample is a bottle that is less than 500 milliliters is 28%. Part C, use a table to determine the probability that a bottle will contain between 498 and 502 milliliters of soda. So this interval here is not going to be counted because the 498 is not inclusive. 498 starts over here. So I'm going to take the 0.215 that I have over here, and I'm going up to 502 milliliters. So it's going to take the 0.405 over here, and I'm going to add these two values together. So 0.215 plus 0.405 equals 0.620. So there's a 62% probability that the bottle that a bottle will be between 498 and 502. Part D, is it possible to determine the probability that a bottle will contain exactly 500 milliliters of soda using the table? And the answer is no. There's a 0 probability of that happening because the probability distribution requires a range of values. So we need to cover a range of values. Okay, the interval, if you just took one single 500 milliliter bottle without a range, then your interval width is 0. And when your interval width is 0, then you cannot find the area under the curve. So it doesn't work. Part E, 2 scatter plots are shown below. The first is a plot of frequency versus volume. The second is a plot of relative frequency versus volume. Compare the two graphs. What is similar and what is different? Well, right away you can see the two graphs have a very similar shape. In fact, so similar shape or even the same shape. However, the differences come into play when you look at the y-axis. And on the first one, we have just the frequency being plotted. Okay, and on the second one, we have the relative frequency being plotted. So what is the difference? Well, the area under the curve for the one with just frequency here, the absolute value of the frequency values, is not equal to 1. So here I'm going to point out that area under the curve is not equal to 1. Okay, so when it's not equal to 1, you cannot use this to find probabilities. You cannot use this to find probabilities. Because remember, the probability is just the area under the curve. So you're going to take any single area. You took this thing right here. Well, what is this? You take 80 multiplied by whatever number you have down here, which could be maybe even 1. If it was just 1 or 2, it looks like 2 if you look at the spacing. Then that's already going to be a number greater than 1. Okay, and your probability has to sum up to 1, which is why in the relative frequency graph we can calculate probability densities, because the y-axis values do not go beyond a value of 1. Okay, part F. Interpret the answers to part B and C in relation to the areas under the probability density graph. So for part B, for 490 to 500 milliliters, we're specifically looking at this portion of the graph. So let me just draw it in here. So at 500 milliliters, we're going to draw a straight line. And from 490, so we're looking at just this part of the graph. Okay, and for part C, we're looking at the interval between 498 and 502. So just a little bit after 500. And 498 would be somewhere around here. So this portion of the graph. So when we're calculating the probability densities, we're calculating the area under the graph, and that represents the probability of 62%. And for this one over here, the probability here is 28%. Okay. And my next example will continue on the next video.